Welcome to The Explainer. Today we are talking about a technology that is just completely rewriting the rulebook for massive ships. We're moving away from the age of diesel and jumping straight into an era of silent, incredibly powerful solid-state propulsion.
So, let me start with a question that sounds a little crazy. What if you could take a colossal 30,000-ton ship and give it the agility, the instant response of a high-performance sports car? How would you even do that? Well, it turns out you start by getting rid of the engine entirely.
And look, this isn't some far-off sci-fi concept. This is happening right now. And it's all because we're finally replacing the very heart of the ship, that massive, clunky, mechanical engine that's been the standard for over 100 years.
Just look at the contrast here. It's night and day, really. On the left, you've got the old way, this incredibly complex, heavy, and maintenance-hungry mechanical beast. And on the right, that's the new reality, these clean, compact, modular racks of power electronics. So what's the fundamental shift here? It's all about how you get the power into the water. The old way is basically a brute force chain. Engine turns a gearbox, which turns a huge shaft, which spins a propeller. The new way is so much more elegant. Power flows from a central bus. It's controlled with incredible precision by electronics, and it's sent directly to motor segments right where they're needed. There's no gearbox, no giant shaft, and absolutely zero mechanical delay.
Now, you might be asking, how is this even possible? Well, this secret sauce is operating at an incredibly high frequency. We're talking 100 kilohertz. To put that in perspective, think of it like your computer's processor. A higher frequency means you can do more, faster, in a smaller package. This allows for a huge 50% reduction in the size and weight of all the components, while making them way more powerful and over 98% efficient.
Okay, so that's the tech. But let's talk about what this actually means in the real world of global shipping, because the financial impact is, well, it's staggering.
I mean, just look at these numbers. The savings are huge, and they're everywhere. You're using 15 to 20% less fuel, your maintenance costs basically evaporate, and maybe the biggest deal of all, the ship is now making a lot more money on every single trip.
And let's zoom in on maintenance for a second. This is usually a massive headache and a huge cost for shipping companies. With this new system, that cost gets slashed by over 75%. You're swapping out these incredibly complex engine overhauls for what's basically just changing a few filters. It's a whole different world.
So, you've gotten rid of over 1,000 metric tons of machinery. What do you do with all that newfound space and weight capacity? Well, for a cargo ship, the answer is pretty simple. You carry more cargo. Up to 300 additional containers, or TEUs, on every single voyage. And that is pure profit. So you add it all up, right? You've got the huge fuel savings, the maintenance costs are practically gone, and you're making more money on every single trip. The result? The entire system pays for itself in less than 5 years. That makes the higher upfront cost a no-brainer.
But it's not just about the money. The way the ship handles is, well, it's a total game changer. Because there's zero mechanical delay, you get instantaneous braking, and you can dock with sub-meter precision. This makes crowded ports so much safer and gives the captain a level of control that was just unimaginable before.
Okay, so we've seen the commercial side. It's impressive, right? But now, let's switch gears. Let's take the same exact technology and see what happens when the main goal isn't profit, it's raw military power.
Because all those things that make a shipping company happy, efficiency, reliability, all that extra space, in a naval context, they become absolutely deadly strategic weapons. And the numbers here are just staggering. I mean, they're almost hard to believe. On a modern destroyer, you get rid of over 99% of the machinery's weight and you reclaim over 95% of the engine room space. The entire idea of a big, central engine room just disappears. So again, what do you do with all that reclaimed space and weight? On a warship, the answer is even simpler. More firepower. A lot more. This tech allows for a 400% increase in a destroyer's missile payload. That's 4 times the punch on the exact same size ship. You have to understand, this isn't just about making a better destroyer. This creates a whole new category of warship. It completely changes the rules of the game for naval combat.
So, let's talk speed. Your typical destroyer tops out around 30 knots, and there's a good reason for that. If you try to push it any faster, the propellers start to, well, they basically boil the water around them. It's called cavitation. It's incredibly noisy, and it's a dead giveaway to any submarine in the area.
But with the new linear jet drive, top speed jumps to over 45 knots. That's a 50% increase, enough to outrun almost anything.
And this is the really crucial part. It's not just faster, it's stealthier. It completely eliminates that propeller cavitation noise. That's the #1 thing that gets warships detected. So it can go faster while actually being quieter. And when you add in instantaneous thrust vectoring, its ability to dodge threats is just off the charts.
On top of all that, the entire power system basically becomes a weapon in itself. That high-frequency power bus isn't just for propulsion, it's a gigantic energy reservoir, ready to unleash huge megawatt-level bursts of power for things like railguns, high-energy lasers, and super-advanced sensors.
And this thing is built to survive. The core components are magnetic, which makes them naturally tough against an electromagnetic pulse, an EMP, which is a huge threat in modern combat. Plus, the whole system is redundant. You can take a direct hit, lose a few modules, and the ship just keeps on going.
And this concept scales up big time. Imagine putting this on an aircraft carrier. You get a 25% faster launch rate for your jets, and you get a carrier that's suddenly fast enough to outrun most submarines. That was basically unthinkable before.
So, when you step back and look at the big picture, the real takeaway is this. We're not just talking about a new type of engine. We are literally witnessing the end of the engine room as we know it.
For more than 100 years, every single ship designer has been shackled by one major constraint. You have to build the ship around this giant heavy engine right in the middle. Well, now that shackle is broken. It opens the door for radical new hull designs built purely for speed and stealth. And that leaves us with one heck of a question to think about. If a ship no longer needs an engine room, that central component that has defined its design for a century, what on earth does the ship of the future even look like? Suddenly, the drawing board is completely wiped clean, and the possibilities are as wide open as the ocean itself.